Consider the following statement. This is one of the very good problem asked in GATE 2024 exam. So what this question says, okay, and this is very easy and very interesting problem. Once you know the solution, then you will realize that how good this problem is. So see, first you must try yourself, okay. If you are watching the following the playlist and come to this question and you are just watching the solution, not thinking yourself, then please, I will say pause for a moment and try to think this problem once again. Okay. Once you think that, oh, now I can't do it, then what's the solution? Okay. Then you will realize the beauty of the question. So see, now there exists a proper subgroup G of Q such that Q modulo G is a finite group. And the second statement is there exists a subgroup G of Q such that Q modulo Z Q statement है ये इस okay. Hello,
Yes, sir.
hello.
Yes, sir.
Yes, sir.
Yes, sorry for the interruption. मतलब network में problem है. So okay, let's continue. So the first statement says that there exists a proper subgroup of G of Q such that Q modulo G is finite. How do you think? Okay, see, uh, suppose that Q modulo G is finite. So you might not have seen such proper subgroups yet. Okay, now suppose that it is finite and it is n. Okay, then what will happen? So let me assume that G is proper and Q mod G is n for some n for some integer n greater than 1. Okay, do you understand why it should be greater than 1? Because G is proper. Okay, G is not equal to Q, so it cannot be 1. If it is finite, then it must be some number greater than some positive integer greater than 1. Okay, so see, then recall, यहाँ recall नहीं, so direct we have लिखिए आप, we have P by Q plus G when added n times will be G, right? Recall a to the power order G equal to identity. G is finite, right? This happens for any A, okay? Right, यहाँ पे खुद लिख लेना आप साइड में, for any A when G is finite. Okay, so here the notation will be addition. So order of G times A will be equal to identity. So what do we get? We get from here that n P by Q plus G equal to G. So when this happens, then you have this n P Q is inside G. So, or you can say NQ. What do we mean by NQ? समझ गए होंगे आप, is inside G. So Q is inside G. Contradiction. Okay. This implies, नेक्स्ट साइन से लिखता हूं. सो यहां इधर आ जाइए. We get G equal to Q, which is contradiction. Okay. which is not so. So our assumption is wrong. What was our assumption? That index is finite. Okay. So first statement is false, isn't it? है ना? False होगा, right? Any questions? Anyone? Is there any question? Everything is clear, right? So now come to the second option. There are two ways to solve the second option. One way I last time explained it. Now another way is solving this question, that suppose we assume that, okay, first you try to think that does there a subgroup so that Q mod G is isomorphic to Z. You will not find it, okay? So let us assume that. We would like to do it by the method of contradiction. So let us assume that there exists some G. So assume, for the sake of contradiction, we assume that exists some G. There exists G, a subgroup of Q, such that this, so now I will give some hint, okay? So Q mod G is isomorphic to Z. We assume this. Okay, so these two groups are isomorphic. All the properties are same, right? So some of you may think that, मतलब ऐसा क्या इसके पास होगा, स्पेसिफिक इसके पास क्या है ऐसा जो क्यू के पास नहीं हो सकता है, उसके कोसेंट ग्रुप के पास नहीं हो सकता. What thing the Z have, and you can use the statement one also, okay? So if you want to show ना कि हाँ हाँ Z cyclic है, so you want to show that Q mod G will not be cyclic. Yes, sir. Okay, Z is cyclic, but there is something another property in terms of subgroups. Think about the subgroups of Z.
Q by G has no subgroup of finite index, जबकि Z के पास finite सारे subgroup finite index के होते हैं.
Right. So finite index will comes into play. So since 2Z is a subgroup object of proper, हाँ, इस proper subgroup object, proper लिख देना यहाँ पे, of finite index. Everyone knows, right? Finite index. So there exists a subgroup, there exists a proper subgroup of which Q modulo G से किस फॉर्म के होते हैं इसके सब ग्रुप्स, राइट? विथ इंडेक्स 2 में लिख देता हूं, आपको पता है इंडेक्स 2 है यहां पे. 2Z का इंडेक्स 2 होता है, सबको पता है ना? सो इसके पास अगर इंडेक्स 2 का सब ग्रुप है, इफ इट हैज अ सब ग्रुप ऑफ इंडेक्स 2, सो इट है, बिकॉज दीज टू आर आइसोमॉर्फिक. सो एनी सब ग्रुप ऑफ Q modulo G इज ऑफ दिस फॉर्म, राइट? वेयर K contains G properly. Okay, properly, and it is properly contained in Q. Why? Because this has to be a proper subgroup. So K cannot be G. Okay, and K cannot be Q, because if it is Q, then this becomes Q modulo G. Okay, so has index 2. Index 2, right? इसलिए order of Q mod G modulo K mod G is equal to order of Q modulo K isn't it? By second theorem of isomorphism. How this follows? Oh, I should. बताओ रिया कैसे कौन सी आइसोमॉर्फिज्म में है? अब तो मैंने बोल दिया। ठीक है, मैं लिख दे रहा हूँ बाय सेकंड थ्योरम ऑफ आइसोमॉर्फिज्म। आई थिंक दैट इज कॉल्ड सेकंड थ्योरम ना। Theorem of isomorphism. I had discussed all the theorems, okay, in a lecture. 4 theorems of isomorphism of group theory. So you must have seen that lecture. So uh, this would be equal to 2, which is a contradiction, right? So यहां से मैं लिख देता हूं. So we get K proper such that Q mod K such that K has index 2 in index 2 in Q, which is contrary to which is not true, right? है ना नामिका? It is not true, right?
Yes, sir.
Because in the first statement we proved that there does not exist any proper subgroup of Q which have finite index in it. Okay, so this is contrary to that assumption. So that's why it's not true. And another way of solving this question is that suppose what I had explained in the last solution also. Let me also say that. So suppose that Q mod Z is Q mod G is isomorphic to Z. Say phi be the isomorphism. So composing with natural map, composing with natural map phi from Q to Q mod Z, we get n onto homomorphism, namely what? Pi operation psi from Q to, which is again not true. Which is not true. Okay. So exercise. Why it is not true? You can think about it. So yeah, we can stop here. Any questions? Huh?
Psi operation.
What?
Psi operation pi.
अच्छा मैंने गलत लिख दिया, एक मिनट. Psi operation, where psi operation?
Means map psi o pi.
Okay. Right. This would be like that. So psi operation pi. Okay. Any questions? Questions are always welcome. So I encourage you to ask. Okay, if you don't understand. So let me stop the recording.